What causes the refractory period after an action potential in a neuron? Negative charge is what's responsible for resetting voltage-gated sodium channels. So here's a voltage-gated sodium channel again. We're at minus 80 or minus 70. It's not the exact charge that matters, it's this negative charge inside. So the negative charge is attracting both the activation gate and the inactivation gate. The activation gate closes first. Once that's closed, it changes the shape of the protein a little bit, of the channel a little bit, so that the inactivation gate can reopen again. First is the activation gate closes, and second, inactivation gate reopens. Remember, it's the negative charges that have pulled those positive charges toward the interior of the activation gate and deeper into the interior for the inactivation gate. 1 and 2 resets the voltage-gated sodium channels. Resetting is required before you can have a new action potential. You need the inactivation gate out of the way and the activation gate ready to be opened by a new minus 45 charge. Talk about the absolute refractory period, the relative refractory period, and then the end of the refractory period. What causes those? You need to think about a series of voltage-gated sodium channels. So I've shown 5 here, and all of them are inactivated. Inactivation gate closed for all. We've made the inside more negative. We're at minus 70 millivolts now. Enough charge accumulating that some of these will start to open. They don't all open at the same time. It depends upon the local charge and random molecular motion. Let's say that this one happens to have a little bit more negative charge near it than the others. First, the activation gate closes. 2, the inactivation gate opens. Now this one is reset, but we're still in the absolute refractory period. Some of them are now in the active state, this one, but that's not enough to allow a new action potential. At some point, another one gets enough negative charge. Again, first the activation gate, then the inactivation gate. Now we have another one available, but that's still too few. Another one. Now we have 3, and maybe 3 or 4 out of every 5. We have the relative refractory period. Some of them are still inactive, but others are now available. We could start a new action potential, but not at minus 45. New action potential at this point might require getting further, more positive, to say minus 30 millivolts. Then another one resets, and now we're at 4. Now maybe the action potential would start at minus 40 millivolts. Finally, the last one resets. First the activation gate, second the inactivation gate, and now we have them all. Now we're past the relative refractory period. Now we're at the end of the refractory period. They've all reset. They reset because negative charge first pulled the activation gate closed, then the inactivation gate open, and once we have enough of them available, we're into the relative refractory period, but we would require a more positive, not minus 45, but minus 30, then minus 35, minus 40, finally back to the end of the refractory period, and now we could get a new action potential at minus 45 millivolts.